Sorry about that.
This. What I do.
Wow, this is so cool.
Oh no.
What happened?
I forgot some 32s, I think.
Hey.
Yes. And x2 is not defined because this is supposed to be x2. Cool. That doesn't seem right, but I'll stare more at this later.
Okay.
That should be a little bit more than that value. And I actually got like a really huge negative number. Oh well, neither here nor there.
Interesting.
But yeah, very cool algorithm to look up and put some hands on. It's just very cool to see how programming, 20, 30 years ago was just so much more about interacting with the kind of actual like brain of the computer, as opposed to now when we're just so abstracted, right? Python's so easy to talk about.
Yes, it is.
And easy to just say something about. Yeah.
I can send you the file, Michael, but I don't think this file is gonna open on a phone.
Yeah, it's almost definitely not going to open on a phone unless you have a way of opening Jupyter notebooks on your phone.
But just in case, I'm gonna send it to you.
Nice, Aiden. This Jupyter notebook is really great. It's a big, oh, okay.
I'm gonna send it to you right now.
Yeah, I would recommend doing this on your laptop. It's just preference. I believe PyCharm handles the IPython notebooks now just the same as Jupyter Notebook does. So I don't think it really matters.
For people who joined late, you guys can download this Jupyter notebook file and set it up so that you can follow along with Sam.
Mm-hmm.
Side question. What's the difference between using a notebook versus PyCharm?
I just quickly answered that before.
Oh, okay.
I don't think there is a big meaningful difference anymore. There used to be. Python Notebook was a pretty specific format, and now it's not anymore. Which, thank God for open source, right? Open source is the best thing in the world because we have this ability to just constantly build off of these, off of other things that other people make, because they also got frustrated at a very similar problem that we had.
True.
I'm gonna grab a glass of water before we start while we're doing the introductions. And then you should be ready to go.
Yeah, we can let Vivian share the screen later.
Sounds good. Let me bring up the right window, start sharing. Can everyone see my screen now?
I think Sam is sharing, so.
I have stopped sharing.
Okay.
Feel free to share, Vivian.
Yeah, can you see my screen now?
Not yet.
Not yet.
Okay. Hello, everyone. Can you see my screen now? Awesome. Are we ready to start, or should we wait a little bit?
Maybe 1 more or 2 more minutes.
Okay. Sounds good.
And in the meanwhile, people can start downloading the file so they can follow along.
Okay. Welcome, everyone. My name is Vivian. I'm the school director of NYC Data Science Academy. Welcome to today's event. Before the event officially take off the ground, I just want to introduce you who we are and who was today's topic and who is the speaker today. So NYC Data Science Academy was established in 2013. We have been luckily in this industry for the past 8 years. We recently got fully national credit, so which means we can accept federal financial aid. We can accept 529 funding. We also accept a lot of corporate sponsorship if you want to study with us. Yeah, we offer all kind of programs. So if you're working professional, there are a few offering will work well for your schedule. If you are currently in school or you are very new to this field, we have all levels of offering you may consider. The best way you can figure things out is browse our website. We have bootcamp courses. You can also contact us through phone call or email. We have an admission officer. We have a support team to help you to figure out what would be the best fit for you. Okay, so today's event, we're going to focus on data analysis with Pandas. Our speaker is Sam. He is an assistant instructor at Academy. Also, he helped to coordinate the online bootcamp. A lot of online students who are working professional work closely with him. So for today's event, you can share your thoughts through chat. You can mention you want to chat with all the panelists and attendees. And we luckily got a quote from founder and CEO from Course Report with over 8 years of experience teaching data science and 4.8 out of 5 review rating on Course Report. It's not surprising NYC Data Science has become the only accredited data science bootcamp to receive ACCT accreditation. So we are very excited for the bright future with accreditation. So as I mentioned, we offer intensive programs such as bootcamp. We also offer part-time class to fit all kind of needs. We are the only bootcamp teach both Python and R. We offer hands-on learning with 4 industry projects. We offer lifetime job support. So many students who graduate from back in 2013, 14, 15, when they look for their second, third job, they reach out to us and keep close with our network. We have alumni across the globe, around 2,000 alumni working in the industry now. And since we start to offer bootcamps to run the in-person bootcamp from 2015, we have been rated the best bootcamp for the last 5 years. Since we start to offer online program, we have been rated as the best online bootcamp. So the process to know whether it's a good fit or not is pretty straightforward. You can go to our website, which is nycdatascience.com. You can pick any program like data science bootcamp or data analytics program, or just click apply. So you can give us your information for assessment. Usually it's a 15 minutes to half hour behavioral interview. Then we have a tech assessment for you to complete. The goal is not like to see how well you can code. It's more like understand your thinking process. So if you don't have coding background, it's fine. We want to know how you think of problem solving. Okay. So before we get started, I just have 2 more slides to go over. We offer remote live, which means the class happens lively. Also, you have option to join the class in person in New York City. We also have 2 online programs, which is full-time, part-time. So based on the length and whether you can make yourself available in person or fully online, you have 3 different choices. And our next starting day is September 27th. Our in-person and remote live bootcamp admission already closed, but I think we still have online bootcamp spots if you're interested. And for the November 8th start, we only have online program available. So for the analytic bootcamp, we have both remote live in-person option and the live option available for September 27th and November 8th. Just want to let you know. Feel free to ask any question in the chat. I will support Sam along the way during the event and answer a few questions. Yep, that's mine. So Sam, it's your turn.
I was grabbing the mouse to my desktop computer and was like, why doesn't this work? So, hi everybody. As Vivian has said, my name is Sam Audino. I am a boot camp coordinator for the remote online boot camp, the IDL program, which is interactive distance learning. If you take that program, you'll be interacting with me and some of our other wonderful IDL coordinators. I believe the recording will be shared. And I am here today to teach you about Pandas. Pandas is a library that we use for data manipulation in Python. It also has visualization tools. You can do a lot with Pandas. Pandas is a really, really fascinating library. It's built on this other library called NumPy, which is a very wonderful library that allows us to do calculations very quickly. And so with those 2 things combined, Pandas is kind of a really nice, graphical way to view the data. And then NumPy is this really powerful engine that sort of powers the whole thing. So thank you for joining once again, and we'll kick it off. So as I said, we're covering Pandas and we're covering NumPy to a much smaller extent. We're also covering how we do visualizations using these. So the topics that we will cover will be getting started with Pandas, reading and saving data frames, inspecting and manipulating data frames, grouping and aggregation, as well as data visualization. And I'll just take a brief moment to point out what files you should have gotten in your download. And so we see here in the file viewer of Jupyter Notebook, you can see we have our IPython notebook. We have the user guide, which is a helpful guide for our data. As we'll find out, the data is very, very, very complicated and a little encoded. So we'll actually need to use some techniques in order to uncode the data so it's a little bit more useful for us. Images is just a couple of images that we use in the Jupyter Notebook. And then we have our data. You should only have the 2018 utility sampled CSV in your data. The files are shared via the Google Drive link in the chat. So if you don't have them, please download them from there. Great. So let's go back to the notebook and let's start talking about code. Great. So the first thing we have to do is with packages in Python, you don't just get them, you have to import them. So you kind of have to ask for what you want. In this sense, it's nice because this means packages can have names that are used in other packages, which is kind of a little bit of a higher level concept. So we won't go too far into it, but it essentially means that everything is separated very nicely. So nothing, unless we want it to, can really interact. We go over a really basic and fundamental command, the import. So when we say import NumPy, I'm asking, please give me the package NumPy. The package NumPy is this object that actually contains a whole bunch of things. And so we'll use this period to denote when something is inside another object. This would be often referred to as a method of the object or of NumPy here. So when we import NumPy, we can see that we can take the square root using this numpy.square root. But what else can we do? And so when you have a new package, and if you don't want to look through the documentation that they so often have online, we can instead use this dir function, which really just stands for directory. If you're on a Windows machine, you may know dir because it's part of your command line. It's a command line function that you can use. And so we can see when we call dir on NumPy, you can see that there are a whole bunch of things. So many different things. But we can see that there are a couple of things that actually look like things that make sense to us. We have adding. We've got a max and a min. There's something to see any. So we can do something that's a Boolean a little bit later. Or we can make an array. You can see there's a lot of different methods. There are a lot of different methods contained within the NumPy package that are really useful. And I encourage you to explore a little bit more on your own. So to continue through our code block, we say the square root of 16 is equal to this NumPy square root of 16. We can see also, if I want to get the documentation or understand the function a little bit more, I can go inside of these parentheses and hit Shift Tab. And this will give me a big introduction essentially to what the function does, return the non-negative square root of an array element lines, and all of the parameters that it will accept. So essentially, what arguments can I put into the function? And we'll bring up this documentation another couple of times, just to make sure everybody understands it. Another thing that's important is we have to ask it to print out to console. And so we'll say print. The F is essentially just formatting. We'll go over this. We go over this more in the program. I won't really go over this much more here. There are some notes on it. And essentially, it just allows me to do this nice printout. You see, I have this square root 16, and it prints it very nicely in this string. And then we can also see the value of pi. So NumPy, being a math package, has the value of pi stored for easy use. And a lot of the text here is going to be sort of repeating what I said. This is sort of supposed to work as a standalone document. So if you are able to, or want to look back over this after on your own, you will have more than enough resources to actually look through it on your own. Great. So it's really annoying to have to type NumPy every time I want to get something from NumPy. It's 5 characters, and after a while, over the course of your entire programming lifetime, that's going to suck a lot of time out of your day, those 3 extra characters. It kind of sounds crazy, but it really is true. You want to shorten a lot of things as much as you can. So we're going to go with a very well set convention in the field, which is we will make an alias when we import NumPy. An alias is just a different name for the same thing. So in this instance, we'll say import NumPy as NP. And when we say import NumPy as NP, we are using the alias NP in order to access those things stored in NumPy. So it's still the same things that we had before in NumPy. It's just with a different name. NumPy by any other name will be just as sweet. And so we can see that we get the same printout as we did above. The NumPy and NP are equivalent. And so now that we've built a little bit of that foundational base, we can now talk about pandas, because we've talked about importing packages and we've talked about aliasing, which are 2 very important things. You could alias either of these things as anything you'd like. It's not going to give you an error, but people will not really like or enjoy interacting with your code. The NP for NumPy and the PD for Pandas is essentially an industry-wide standard. Everybody does it. No matter what code you see it in, it almost always will be written like this. So to sort of make sure that you're fitting in with the rest of the data scientists, make sure that you're hitting that import NumPy as NP, import pandas as PD. And eventually it'll just be second nature to you. You won't want to use a name. You won't want to use any other name. And so we'll import pandas, and then we'll show all the versions that we have. As we can see, we see pandas. We see the install. We also see, we see our pandas package, we see NumPy, and a whole bunch of other stuff. So these are essentially a lot of the packages that I have downloaded. And it'll just show the versions of everything that's essentially connected to that Python library. Great. Yes. So Karim brings up a question in the chat, which is NP show versions doesn't work. That's because NumPy is a different package than Pandas. Pandas has a specific method written in it that is show versions, that is all exclusive to Pandas. If you want to get the NumPy version, you have to do NP and then version with 2 underscores on either side. And this will give you the NP version. Hilariously, using Python's show version or Pandas show version, we actually get this same result down here. It shows us what NumPy is. So good question, Kareem. Great. So with that being said, we are allowed to move forward. And the actual important part, so we imported the package. The important thing to remember from this part is we're importing the package as PD. And if you use a dot, that's accessing a method of the package. And so we'll use this quite often, this dot. So now that we have that out of the way, we will look towards working with the data, which is really the most important part, right? Pandas is for data management, data wrangling, data cleaning. And so here is how you make the sauce. You read in the CSV using the pd.read CSV command. The pd.read CSV command is very simple. It just takes a string where the string is where the file is located. it makes the assumption when you run it that you're starting from wherever the Python file you have is located. So in this situation, it's making the assumption that I am here in my file system, and then I only need to click through to data, and then to my utility sampled. And we can see that here in the writing, we have data, we have our file separator, and then we have 2018 utility sample.csv. And I'll run this. It'll take a second to load in. And now we have loaded in our data and we can look at it. That's data, right? And as you might be able to tell, if you look at this data a little bit more, a lot of this data isn't really helpful at first glance. We have a birthplace that's a number. The day of the weeks are also in numbers. Birth time is something. It kind of looks like just the 24-hour clock, but with no separation in between hours and minutes. So as you can see, sometimes you'll want to open up the data and immediately jump in. But unfortunately, we can't really do that in that situation. So what I want to do is I want to just very briefly go back over to another file that we've included in the Google Drive. And that is this user guide PDF. And so the user guide PDF is the user guide to this data. I know this is going to be a little bit small, so let me try to get this as big as I can. Cool. So this is the user guide. So we'll see that there's some information about the how the data was collected. There is a table of contents which will let you navigate this very easily. And then there are some detailed technical notes, and then introduction, and then some really, really in-depth stuff. Right now, I'm going to not really deal too much about some of the in-depth stuff. I just want to show you guys the documentation. Great. So this is essentially the documentation. This is kind of like a dictionary for your data. We'll see that these values over here, the 01, let's say for birth month, the 01 stands for January, 02 for February, 03 for March, 04 for April, etc. So reading the documentation for your data is going to be very important for actually understanding what it is. It is course platform agnostic, yes. So you are essentially, like transferring all of this information into something that's stored a little easier. It's much easier to store a 2-digit number than it is to store that many characters, especially when you're working with a lot of data. We've sampled down the data, but the original data set has 3.8 million rows. And so writing Wednesday or January, 3.8 million times is a huge amount of file size difference between writing 01. A data dictionary should be provided for most data sets. The majority of data sets will have them, especially if they are official or if they have any kind of encoding like this data set does. Great. So with that out of the way, we understand that, okay, this is a little complicated. The data is a little bit complicated. We can't just immediately work with it, but let's cut things down a little bit. Let's reduce our scope, because that's a very important thing in data science, is sometimes you need to just reduce your scope and really just cut down on the amount of information you're looking at right now. And so we'll take a subset of the columns. We use the strings that indicate the column names. So we can see birth year, birth month, there's a birth time, and a birthday of week. And so we'll want to grab these 4 columns. The way that we do that is by indexing. So if you're familiar with Python, you know that the square brackets allow you to index in a lot of different data types. That's also true for pandas. Pandas sticks to the Python convention that square brackets means you're indexing. And so here we'll make a list of the columns we want. And then we want to make a subset using that list. The reason we use a list here is because we're working with dimensional data. And so we can see that I get back. The df is just a variable name. We saved at the very beginning our CSV file to df. We call it df because it is a data frame. Cool. So we're doing 2 things here. We're doing an indexing here. And so we're saying, please give me back this collection of columns, which is a good way to think about it. If you want 1 column back, you can use just a string. But if you want multiple columns back, you need a list. And then we'll say sample. We have a lot of data. You can see that there's even sampling it down to less than 1%. We still have 38,000 rows. And so let's cut it down even further and let's just go to 2,000. And so we'll hit the sample and we'll hit the sample, and sample won't grab the first rows. It will grab 2,000 random rows. And we can see that by the index numbers over here to the side. You see how they're not in order? When we don't use that sample and we just have the data frame printed out normally, you can see that the index numbers are in order. And of course, Python is index 0. Great. So we have this new itty bitty data frame, much smaller, much nicer to work with. It has 2,000 rows and 4 columns. I'm drawing a blank on the package name. I think it's NPC. Yes. So to answer your question, to set a random number seed, random seed, and then you could say like 400. And this will set the seed to 400, so you'll get the same answer every time. We go over stuff like this in the program as well. So I'm not going to spend too much more time on that. Great. So now we have, yes. And now we have this smaller data set. And so let's say I did a bunch of really complicated calculations and I'm crunching all the numbers and I just spent like 3 hours doing all this work. And I want to make sure that my data gets saved, because the reality is this is all in memory right now, as you can see up here. This is essentially if my computer shuts down for some reason, if I lose power, this isn't going to be saved. And so you do need to sort of explicitly save your work. And the way that we do that is we do this toCSV command. And so toCSV will essentially package up this data frame right here, this data frame subset, and put it into a file. And in the same way, from CSV pulls or read CSV pulls from a string, the to CSV writes to a string. And so we're saying, please write in the data folder, write a df write test.csv and see if it's there. And so I'm going to be a hacker, and we're going to do this. And I'm going to use a magic command. I would say that saving the notebook is safe too, but when you don't save the data, you have to rerun the whole notebook. So if you do something that mutates the data, that changes it and takes a really long time to run, then you're going to have some issues, because when you start up that notebook again, you're going to have to run the whole notebook to get back where you were, which is going to take a lot of time. And so it's important to save to the CSV once you're essentially at a point where like, oh, I've changed something meaningful about this data, to a point where I would like to save this as a separate copy. And so I did something a little bit funky here. This will not work if you're on a PC. You have to use different commands. And we go over that at the beginning of our course. I used Linux commands here in order to check to see if I had written the file or not. And so essentially what I'm doing here is I'm seeing, oh, this is a file. This is a file. These are the files that I have in my data folder. This is the map command, Aiden. If you're on Windows, it won't work. I don't know if Jupyter exports to Parquet. You can, yeah, we mostly work with CSVs. So important thing about CSVs is CSVs have a very important line at the beginning, which is called a header. The header essentially determines the, Aiden, it's like a subtraction sign A, not a tilde. And we can see when I read the CSV and I set my header argument to none, I get this weird thing that happens. And so we see these, my beautiful column header names, are now part of my data, which is not something I really want. These column headers are not in observation, so we don't want them in there. And this is because I have this header equals none argument. And the question could be, what other methods or what other arguments does read CSV have? And the answer is a lot. You will use some of these, sometimes you will not. As you get more comfortable with working with data, there may be ways in which you can read it in, which will help you slightly. But for the most part, you won't really mess with a lot of this stuff. And so remember, don't change the header to none unless you really need to, or you know your data doesn't have a header. Yeah. And so that was just a brief overview about how we read in data and how we filter and select certain things in the data. Now we'll be talking about different ways to look at parts of your data via several commands that are just real easy and nice to use for viewing specifically. Yes, I would leave the header equals none out, and no, we recommend making a cheat sheet, because you eventually get to the point where doing it more and more and more will then build that information. I find a lot of the time it's much better to build an understanding of where the information is located first before you try to memorize. It'll be easier trying to go to find where the information is located, and then through that repetitive step, you will learn. Cool. So we're looking at these different functions. We've got a bunch of different functions here. We have the head function, which shows the head of the data frame, la tête. And so we can see here that this gives 5 rows. This is the default of this data frame. You get 5 rows. I can also make it give me back 10 rows. I can make it give me back 1 row. And you'll notice it's always the first row that starts it, and then the second row, third row, etc. df tail is the exact opposite. It is the tail. And so we see the last 5 rows of the data frame. And once again, I can see the last 10 rows, or I can just see 1. Oh, that's 11. Just see 1. There we go. We've talked a little bit. No, remember df head. So important variable names, everybody, variable names. So df is our original data set, right? You see, we have a million columns we haven't filtered. We saved earlier this to df2 and also to df subset. So we are working once again with the whole data set. Once again, the sample command will grab 1,000 random rows. It's actually just doing a normal distribution, and then you pick all the integers. But you'll learn about that in the course too. The nice thing about sample is, let's say I don't know the exact number of samples I want. I just know the amount. I can instead say sample with the argument frac for fraction, not fracking, to 0.5. And we'll see that the 0.5 means 50% here. So I'll get 50% of my data back. When we have replace equals true, that means when we are pulling values from our data frame, we don't care if we pick the same value twice. We can see here. So let's say I didn't know at all what replace did. So I would go here, put my cursor in between the parentheses of this sample function, hit Shift and Tab. And then I can see all of the different arguments again. And so we'll look at replace, because I didn't know what this function did. I do know what this function does, but for sake of argument, we allow or disallow sampling of the same row more than once. So essentially, what we're saying here is when we have replace equals true, I can pick the same thing twice. And we have half the data with all of the columns. And so those just a couple of ways that you can very quickly take a peek at your data. A lot of people prefer, actually, as opposed to doing either head or tail, some people prefer to do a sample 5. Because in this case, instead of looking at the first 5 entries or the last 5 entries, you can look at a random number. You can look at 5 random entries, which are a little bit nicer because there may be some things that happen in the beginning or the end of the data that will mislead you to trends in other parts of your data just by looking at the first 5 rows. But once again, is a totally preference. It's not really like, a lot of people do it a lot of different ways, let's say. Great. And so we've been able to take rows and look at different rows, and we've been able to take columns and look at different columns and cut those down. Now let's talk about sorting. Sorting, we can sort the data frame on a specific column by specifying that column using the sort values function. So this sort values function, we'll run it. You can see that when we go over to the mother's age column, we now have all of the mother's ages sorted. So we can see 13 all the way up to 50. But let's say I want to do a little bit more complex of a ranking. I want to rank one thing and then rank a second thing within it. So the mother's age and then birth month, let's say. And so when I do this, it will first sort everyone by mother's age, and then we'll sort everyone by birth month. As with filtering on columns, when you are doing something with multiple columns, you should give your pandas functions lists of those columns as strings. What about descending? Well, what about descending? You just, once again, just to go over it, you can open the documentation using Shift Tab with your cursor inside, and then I will use the argument ascending equals false. Yes. And now we have the exact opposite way. No. So something that I forgot to explain about these methods is, let's look at some of these methods, or let's look at the df sort value. And when you see that ascending equals true here, that means that true is the default value. So this is answering Sherry's questions, which is, so in the code, we don't need to specify the value from least to greatest. And that's true. When we're using sort values, the default for sort values is ascending. When you look at the documentation and you see these, like ascending equals something, that means when you run the function and you don't specify it, that's what it's going to be equal to. So I hope that answers your question. Yes. Great. Cool. So now we're finally getting, let's get back to actually working with the data a little bit more. And we'll actually want to set up to decode some of our data. So remember, our data is encoded. We have our birth months as numbers and days of the week as numbers, and it's all numbers. And we want it not as numbers. We'd like it to be a little bit more human readable. So we want to make a data frame, but we want to make essentially like a translation data frame. The idea is here that we'll store the information of what number refers to what day of the week, and then use this data frame to attach it to the other one so that now we have that completed information there. This is just one of many different ways that you could do something like that. So we'll have to talk about the actual PD data frame setup. Essentially what this is we have we want two columns here. We specify by name and number. And then the default is to assume that all of these are rows. So when we have it here and we specify the columns, we're making an assumption here that Sunday is the first term in our first row, and 1 is the second term in our first row. Monday is the first term in our second row, and 2 is the second term in our second row. And so we can see this very quickly by just running the function. And we'll see that the name and the number show up as our column headers. And just like I said, Sunday is 1 because we have them in the same list together. Monday is 2, Tuesday, Wednesday, Thursday, Friday, Saturday, etc. And so we've created this sort of translation data frame. So for those of you familiar with set theory, merging will be a little intuitive because you guys understand unions and intersections and things like that. For other people, let's think about Venn diagrams. Venn diagrams are really cool and are a great way to visualize and help you visualize merging. Here, we have this data where we want to merge these names into our data set. And we want to be able to merge that with the days of the week. Here it is. So we're essentially trying the overlap here. The overlap of our Venn diagram is the birthday of week and number, because these numbers correspond to real values in this data frame. And all we're doing is we're just making those values match up. So it becomes important which side you're on. So in this case, DF and day of week, yeah. So DF is on the left side here, and day of week is on the right side. And this will be important. As we can see, we need to specify what columns are going to be the columns where we match. So as I said, the birthday of week is the column that's encoded into a number, and the number is the name of the column in our smaller data frame that holds this information. So I use this PD merge command, and we list the arguments above. So something to note here too is if the name was the same in both data frames, I would be able to just specify that one name by using the on argument. But since it's not, I have to use left on and right on. So we'll run this, and it'll take a second because we're starting to do some complicated stuff now. We're matching like 38,000 rows to single values very quickly, adding them and then re-spitting out all of that data. As we can see here, we still have our birthday of week, normal, but all the way at the end, we have name and we have number. So we have successfully added, we have attached onto the end of the data frame these two names, or these two new columns that are name and number. And as you can see, every time we matched a 4, we added the Wednesday and 4 data points to that row. And wherever we matched 1, we put Sunday and 1 on that row. Great. All right, I just solve the code. We're all good to go. We can do some analysis, but wait. A lot of functions in Pandas are non-mutating. So you may be wondering, where did my columns go? Somebody stole my columns. I put them right here. I had just merged them so neatly, and someone has taken my columns. And that's a shame. But the reality is, with non-mutating functions, Pandas is trying to let you try stuff out without fundamentally changing your data. So in this situation, when I run this merge command, it returns to me another separate data frame. So this isn't DF. This is not day of week DF. This is an entirely new object that's been created by merging these two previous objects. So that's very important to keep in mind. A lot of these functions are non-mutating. So what we'll have to do that we do below is we have to set it back equal to DF. We have to update our variable in order to be able to go forward with our analysis and keep those extra rows. So we've got our columns in now. Yes, you can also use Tigran says, can we use an argument? Yes, you can use, there's a specific argument called in place equals true, which you can set in a lot of the pandas functions, which will make them mutating functions. I warn against it at the beginning, just because sometimes you'll accidentally run code or something that you didn't really mean to run. And you'll essentially have to restart your whole notebook and like start from the beginning. So just be careful with in place. I find in place is really nice if you're writing functions that handle certain operations and data frames. So yeah, good bringing that up. Yeah, cool. So we have our newly merged data frame. As we saw above, we have this identical column. We have birthday of week and we have number. These are the same column. We are repeating data. This is a bad thing to do. So we're going to drop one of them. We want to get rid of one of these columns. So I will do the df drop, do that df drop. And you can see that number is no longer part of this. We've shuttled number out of our data frame and into the Aether with only birthday of week to remain. And if you'd like to drop multiple columns, you can add a list. If you would like to make this a mutating function, you can use in place equals true. This does not change the data. So we'll have to resave it at the end. Here is the rename function, which allows us to rename columns. It's pretty straightforward. You want to add a dictionary because the dictionary will allow you to specify a column name and then what it should be turned into. So here we have the column named name, and we would like to change it to birthday of week name. And we can see birthday of week name shows up here as we've renamed it. But we see this number column has shown up again. And so once again, we have to save everything back. So let's save everything back. And this brings up probably one of the most important and useful things about pandas. So before, we've only really been doing one command at a time, right? We only ever really call one method at a time. We say df drop, and then we say df rename, and then we save, But here, we're starting to do something a little bit more, a little bit further than what we've been doing before. And that's called chaining methods. In pandas, you can do this really cool thing where, because pretty much everything in pandas returns a data frame as an object, you can just keep slapping methods onto the back of it. So we know that df drop returns a data frame. So when I'm done dropping the column, I then want to rename a column of that data frame that was produced by this df drop. And so I can chain these functions together really quickly in order to write a really powerful line of code that handles a lot of different things. As you can see, we finally saved it. So we'll go to the end and we'll see that we only have our birthday of week name, which is under the right title now, and we've dropped the number column. Great. Does anybody have any questions about this section before we move on to selection and filtering? Chaining is pretty cool. So I get that. If it's a little confusing. Cool. I will move on then. So just to quickly go over the two questions that were posted, what does left on and right on do again? Left on and right on specify the columns that you would like to combine. So as we saw before, it was our column that we wanted to combine was day of the week and number. So these columns match up in between our data sets, right? If I see a 4 in the, yes, running rename should bring back the dropped column in your data frame because we have to save it all at the end, which is the last thing I just explained. Okay, so just quickly, right on, left on is essentially saying left, my data frame on the left, this is the name of the column that is matching with the data frame on the right, and right on specifies that name of the column. I think it's really easy to remember when to use dictionaries as opposed to lists. So a lot of people are asking a very similar question, which is when do you use square brackets, lists, versus curly brackets, which are dictionaries, versus parentheses, which are tuples. We don't really talk about tuples in this course, but we do talk about it in our actual data science course. So the way that I like to think about it is a list is a collection of objects. A grocery list is a list of things, right? And so whenever you need a list of things, but you don't really need to specify anything about it, you want to use a list. So you'll want to use the square brackets. A dictionary is something that you look things up in, right? This is what a dictionary is IRL. Like you pick up a Merriam-Webster's, you look something up, and it tells you a definition. There's a key that you're looking for that gives you a value, which is the definition. So whenever you need to convert something or change something or store data in a way where essentially you need a reference key, and then when you have that reference key, it gives you something else, that's when you use the curly braces or a dictionary. So curly braces are really good for that, translating, right? And we saw that a little bit with the rename, right? Because we can see that, oh, I have this rename function that's going to take this column and turn it into a different column. So so the key of my dictionary, which is what's on the left-hand side, is the column I want to find. And the value, which is the right-hand side, is what I want to change it to. And tuples are immutable objects, and we only use them in very specific situations. Yes, Aiden has a very good, concise definition. That is, a dictionary uses a key to get a value. A list uses an index to get a value. Yes. I hope that clears up a little bit the confusion. Yeah, but yes, a list in R is like a dictionary because vectors are more like lists, but they're kind of like arrays. It's really confusing. It's not. You'll find as you go through the course, the data types are slightly different in R and Python, but a lot of the thinking is kind of the same. They're just called different things. So great. I hope that clears up some of the questions. And we will, and a lot of stuff in R is also non-mutating, which is why we have dplyr, which we teach in our course, which is really great. It's very similar to the Pandas chaining. Cool. So let's move on to selection and filtering. Here, we've talked about selecting certain columns, but we haven't talked about selecting certain rows. So let's just go over selecting certain columns again. So we'll select these 5 columns: birth year, birth month, birth time, birthday of week, and birthday of week name. And then we can use this to subset them. This is non-mutating, of course. So we need to save it back if we would like to save it. And so we'll save this as df2. I'll just show this right now, why not? So something as well that is important to keep in mind is the order in which we give this list. So let's say I wanted birth time to be first. I'm going to cut it out of here and place it at the beginning. And so we'll see that the columns are now rearranged. And so thank you, Martina. So the columns are now rearranged, right? Before I had birth year first, but now specifying birth time first, it puts birth time in the first column. And so let's set this back so we're all on the same page. And remember, you can use Control Z or Command Z or Control Z on Windows to undo what you type. It's just like a normal text editor. Great. So now we have to start thinking about, how do I filter rows? Columns are easy because you just specify the name of them. You say, I want, yes. Single quote is the same as double quote, except in the situation where you open a string with like single quotes or double quotes. Because in that situation, let's say you open a string with double quotes, you'll have to use single quotes inside the string to represent quote marks. Otherwise, you can't do it because it'll essentially just end the string. You can also use escape characters, which we'll teach you about in our program. Great. So we can do some really, really cool stuff with Pandas. Pandas was built on being able to really work very well with data. It was made by this company called 2 Sigma, which some of you may have heard of. And so we can actually use just a regular Boolean statement. Yeah, big, very fancy hedge fund. We're trying to ask now, I would like the birth months 7 to 12. So July to December. And so we see here for the DF birth month, we say, I would like df.birth month to be greater than 6. But for the observant of us, I'm doing something a little different here. So here, I'm just saying df dot. So an interesting thing about this is all of the columns are actually specified in the structure of the data frame as methods. And so in this situation, we see that birth month is actually one of our attributes. So we're allowed to say dot birth month. But we could just run it really quick to see. You can see there's a million different, yeah, so here we go. We see that when we look at the directory, of our data frame, we can see all of our columns are actually attributes. So we see that birthday of week, birth month, birthplace, birth time, birth weight, birth year. Boolean is a Boolean, so that's not the same. But you can see that we're actually able to specify these columns using the dot. Great. So now that we can create this list of Booleans, how do we actually use it? So we use it pretty much in the same way that we use the column indexing. You just stick it in some square brackets and you slap it on the end of the DF and you're good to go. And so here we see that, oh, wow, great. I've reduced a pretty significant amount of my columns or amount of my rows. I still have all of my columns. And so we've successfully filtered our data set using a Boolean statement. Booleans are just true or false. It's a funny name for true or false. However, let's say we want to do something a little bit more complicated, let's say with strings. We can use this isIn function, which is great. So we say the isIn method will check if the value is contained in the list. Pretty straightforward. So we'll say, I would like Sunday, Monday, or Tuesday. I specify the birthday of week name from my DF, and then use isIn. And you can see I get the same sort of thing. And we'll see the filtering too. As you can see, we get a reduced filter or a reduced data set. And you can see that we've got a Tuesday, we've got Sunday, and Monday is somewhere in there. We'll show you how to figure out how Monday is in there in just a minute with this function called value counts, but a little bit later. So those of you who've taken formal logic, this should come at no surprise, but for those of you who have not, we can combine Boolean statements. Depending on what kind of operator we use, whether it's the and or the or, and there's a couple of others too, but we won't really talk about them. It will check the true and false values. So when you check, in this situation, the DF birth month is greater than 6, and DF birthday of week name is in Sunday, Monday, or Tuesday. So in these situations, I find it's a lot easier to think about it in words as opposed to code. So we're saying we want all of the rows where the birth month is July or later, and the day of the week. So there's that and, right? And, so it has to be July or later, and the day needs to be Sunday, Monday, or Tuesday. So we'll see that this gives us back a data frame that is smaller than either of the two other data frames, because this is an intersection of these two values. And we'll go over a lot of this kind of stuff in way more depth in the program as well. But yeah, so that's essentially one of the ways that you would do filtering for rows, just specifically rows. We can think about aggregation as well. Aggregation is a very important part of data science. Yeah, Kareem, it is kind of like a find function. Yeah, except you're essentially checking all of the individual values of your column against whatever is in your list, right? Great. So group by aggregation in general is really important for data. We do it all the time. We like to look at sums. We like to look at annual reports, returns, investments. These are all essentially just sums. There's also, some other things that we do. We look at medians, we look at means, and, we have to be able to group the data in a way and then aggregate it, because it's not going to be really meaningful if the only thing that you can do is just take the average of the whole data set, because that's fine. Maybe that'll give you some insight to start, but most of the time we're really trying to look at these individual values for different groups. So in keeping that in mind, we're going to approach this trying to understand if there is any meaningful difference. So I have a kind of hypothesis here that there is no meaningful difference in the birth month for how many babies were born. We'll see if I'm right. We'll see if I'm wrong. So we want to see, does month play a huge role in how many babies are born? So I will do a group by. In the group by, I specify what column I want to group by. As with a lot of these functions, you can specify more than one column. So pretty much anytime you can put in a single string, you can almost always put in a list. And so this df group by returns a very specific group by object, which allows me to do aggregations. So here in the next line, I start to begin my aggregation. I am just going to count, because that's really all I care about, right? My question is, how many babies are born? It's not how many babies are admitted to the NICU. It's not, it's not what are their age. I just need a raw count. And so with that in mind, we specify count. There are a bunch of other ones. There's sum, there's mean, there's median, pretty much all of the hits. And so you can definitely play around, look at the documentation to see what other functions there are for that. So here's something that's a little strange, but will make sense as you do this more. When we do aggregation functions like count, it will essentially just count the number of rows for every column. So it'll just be the same number like 108 times. But we don't want that, right? We just need the count one time, because that tells us how many babies there are. So the way that we do that is we just take an arbitrary column that's not your group by column, and then we just filter based on it. So that's what this is. This double brackets, when referring to a single column, returns a data frame instead of a series, which we'll also go over a little bit more in the course. Not here, we don't have time, unfortunately. But so we'll get the data frame by using this double bracket, and then we'll use the rename in order to rename our birth year column to something that actually makes sense, which is number of births. You cannot use the column you're grouping by. The column, and technically the column that you're grouping by does not exist in your data frame. It's the index. As you can see here, birth month. Yes, Kareem, we're ignoring year because, so I got a couple of questions. We've got, can you use the column you're grouping by, or does it have to be a random one? I just answered that. The answer is it has to be a different one. It has to be different than the one you're grouping by. So we are normalizing it, sort of. It will compare months regardless of year. Yes, that is correct, Kareem. We are essentially kind of taking an agnostic approach to year and just combining all of the data together in order to see what happens and to see the aggregation. Obviously, if we had all 3.8 million rows, you'd be able to get a very much better look. But also, this is only for a year anyways, so it doesn't even matter. Because it's the 2018 utility data. Jiasheng, why not create a new column? Well, there are only 12 months and there are 38,000 rows, 3.8 million in the actual data set. So adding a column to the end of that data set would essentially just be adding a huge amount of duplicate information, right? Because anytime birth month is 1, it will have numbers of birth 3,089. And that's just not useful. That just takes up a huge amount of space. Let's say you have 100,000 Januaries, right? Birth month of 1. You also now need another column 100,000 times that just says the same thing. So instead, we'd want to make a separate data frame like we're doing now. We're aggregating, so we're making it smaller into a smaller data frame. And then we could store this in a way that is linked to the other ones, right? And so let's say I wanted to look at the specific number of births. That number will be stored in a separate table because when I want that number, I want it for a really specific thing. I don't need it all the time. I hope that clears up why we're not creating a new column as opposed to just slapping another column on there. Great. And so we'll see here, and we can kind of look through it. It's a little hard to see. It kind of looks like things are more or less okay. You can find min and max births as well, yes. But I will not go over that. We'll go over that in more of the data analysis lectures that we have. I will say that there are commands, min and max, that are based to Python that allow you to find the min and the max of a list or of a series object. Yeah. Great. So up here, we saved birth month groups as our group by object. So here we're going to perform a different aggregation on it. We are going to perform the average, also known as the mean. Yes, PD describe is also very good as well. PD describe will give you the 5-number summary for all of the columns. If you push your data frame in, that's a very helpful command. Cool. So we're looking at a different column this time, and we're doing a different aggregation. We can see that because we're doing a different aggregation, the format in which we specify the single column that we want is also different. So as you can see here, we have this double bracket before, and then our aggregation. Up here, we have our double bracket after the aggregation. So if you have an aggregation that cares about a certain column, you'll want to specify that column. If you have an aggregation to just apply over the whole data set, you don't have to specify the column. Yeah. Cool. So just to show that very quickly, I will delete mother's age from here, and we'll just do average of the whole data set. And so we can see here that I just took the average of every column, which some columns is very helpful, other columns less helpful. So we want to specify a very specific column here. So that's why we include the double brackets and mother's age. And we get back this very lovely data frame, which essentially seems to say in a much more clearer way than the data above that there isn't really any meaningful difference between the month that the baby is born in and the age of the mother. We're going to do one more group by, which will be by name this time. And we're going to see if there are essentially any days of the week that are significant. And so it's really the same setup as before. We're going to grab birth year. We're going to rename it to number of births. We're doing our group by on birthday week of name now instead. And then we're doing count again. And so we can see there does actually seem to be some difference. It would be nice if these were in order, but we'll go over that in a little bit. Oh. There is a way to fix that, David, where if it's not coming up with the variable names or the function names, but I can't remember off the top of my head right now. It is a very common problem that students have though. So fret not, it is solvable. So here we'll be looking as well at the mother's age aggregation. And we can see also how crazy would it be if this is actually true? But the day of the week does not influence the age of the mother. It's makes sense, right? We wouldn't think that, you know, a specific day of the week would have a big impact. Maybe month might have a bigger impact, but specifically day of the week shouldn't really affect anything. Cool. And so, does anyone have any questions before I move on to the smoking risk exploratory data analysis section? We're going to be doing some plotting. We're going to be doing a little bit more aggregation. And we're going to try to draw some more conclusions and insight. Yeah, cool. Great. Cool. So in the smoking analysis section, we are looking at the specific column, which is the number of cigarettes smoked in the third trimester. And so the cigarettes in the third trimester, the higher the number, the more severe the level of smoking. So, and then the admit NICU column essentially determines whether or not they were admitted into the natal intensive care unit. For this reason, or because we're doing the analysis on whether or not it has an effect, there are a lot of cases where the admitted to the natal intensive care unit is actually missing. It's not really missing, it's just U, which is for unknown. And we'd like to get rid of those values. So what we're going to do is we're going to do some filtering. We do double square brackets. In the double square brackets here is just a list, right? So we're specifying a list. We want the SIGs or SIG try 3 and the admit NCIU. And then we see we have smokers and we create one of our Boolean statements by using isIn. And now we can see our whole smokers data set. We see we only have our 2 columns and we have most of our rows, right? We started with 38,015 or 38,000, yeah, 38,015. And now we're at 37,983. So we kicked a little bit of data out, but for the most part, we kept all of it. Great. So here is that function that I was telling you about before. This is called value counts. Value counts is really cool. It allows you to inspect one of your columns. So it only works when you specify a column this way because it's a method of the Pandas series object. And as you can see, this essentially gives you all of the values sorted in most frequent to least frequent based on how many people are in that category. So we have the majority of people smoke no cigarettes. The next highest is 10 cigarettes. It's probably 10 cigarettes during the entirety of the trimester. 99, which I think is 99 or more, is the third highest category. Yes, it is the frequency of the value that showed up. So here is a little bit of a complicated piece of code. We're going to go through two pretty complicated code blocks pretty quickly. I would love to go more in depth, and you can. You just have to come and take our course. So here we'll be looking at the admit counts. And so we're trying to see how many people were actually admitted out of all of these categories. So we can start making some claims about how smoking in the third trimester affects your pregnancy, or affects not necessarily your pregnancy, but your chance to be admitted to the natal intensive care unit. Okay. So we do 2 group bys because we want to count not only the different trimesters, but we also want to count the number of yeses and nos. So we do this double stacked group by. Size is just a very clever and quick way to get the value of how many rows that it has. And then this reset index is pretty important. I can't go into why, but essentially you just won't have the right data type if you don't reset index. Rename is just our rename function. And so we'll just rename it after we're done with it. And then we just look at the first couple of values. Great. So here we go. We have SIGs in the trimester. No, the majority of people who smoke no cigarettes were not admitted. We have cigarettes in trimester 1. Or we have no cigarettes, but they were admitted, which is a very small amount. But still, even if we were to look at the whole data, this still wouldn't be that useful for us. It's hard to really get a sense of what's going on. So what we'd like to do instead is we like to make percentages. It's much easier to see percentages and see, oh, like, does the percent of people admitted to the NICU go up as smoking goes up? Great. And so we're going to write this for loop. I will not be going too deep into the for loop, but we'll go over it very briefly. So vals is an empty list that will eventually be the values for the how many cigarettes are smoked. The per in NCIU is essentially the percent that is admitted to the NCIU. What we'll do at the very end after calculating these, because this whole block is calculating, we'll zip the 2 values together, which actually makes it tuple. And then we'll turn that into a data frame. So the first thing we do is for value in admit counts, SIGs, try unique. Essentially, this says, give me all of the values, all of the different values that SIGs try 3 can be. And then we'll append that value to a list called vals. The numerator is all of the cases where the amount of cigarettes in trimester is equal to or above I'm not entirely sure what your question is. We can hold off on it, and I'll see if there's time after the panel. Yeah, so we can see here that we are looking for at least a certain level of smoking, which is this. And then if they were admitted into the NICU. We see the number of cases in that regard, and then we just sum it. And remember, number cases is just this value here, right? From our previous data frame. Our denominator, which should be all of the values, regardless of whether or not they were admitted. So it's just the first part of our Boolean. So the number of cases, once again, and then we just sum it. And then we make the percent, right? We divide the number of people who were admitted by the total population based on our constraints, and then we get a percent. As we can see, we get that the number goes up. And so as we can see, as you smoke more cigarettes, your likelihood of being admitted is significantly higher. However, as always important, just because something looks very convincing in your data does not mean it's necessarily true. Remember, correlation does not imply causation. Please always be heads up when you're doing data analysis for that reason. Great. And now for the big flashy part, we're going to be doing visualization just to wrap it up. And then I don't know if we'll have questions and stuff after, but this is the creme de la creme. We're going to make some nice graphs. So we'll look at our data frame and the number of births, because remember how before we were a little confused. It was difficult to say whether or not any individual month had a very serious impact on our value. It's kind of hard to just look at a list of numbers and see the meaningful relationships between them, which is why we use graphs. And so here I will generate a graph using the built-in Pandas plot function. This is a really, really awesome function. You can essentially just use dot plot at the end. Sorry. You can use dot plot at the end, setting an argument to the kind of plot that you would like, as well as the title. And then if we save it to this AX, it saves that graph as an object, and then we can edit certain things about that object. So we can edit the Y label, we can edit the X label, we can edit what the ticks say, we can edit how much of the graph that we see, but we'll see some of that in just a second. So here, with the number of births per month in 2018, it seems like we have a really big spike. However, the graph is slightly misleading. The graph is only looking at between 2,900 and 3,500 for number of births, which is a very limited space and really dramatizes some of the differences in between the data. However, we would want to make sure that we're looking at a more reasonable graph that doesn't so aggressively draw the differences. The way that we do that is by controlling the Y limit of our axis. And so here, we can actually give an argument to ylim that is the range that it should go in between. So the matplotlib inline thing is just, it's kind of goofy. It's this weird thing that like you used to need it like specifically, but now you don't need it anymore, but you still need it the first time. So the first time you run this graph, if you don't have matplotlib inline, which is the question, what does matplotlib inline do? It will just say text 050 month, and it won't give you a graph. And then you have to run it a second time and it'll work fine. It's really weird, but it's just one of those things. Programming is quirky. Great. So let's look at the graph again, except this time we're looking at a much more reasonable graph. That looks totally normal. It doesn't really look like there's a significant difference anymore, right? We essentially drew a graph that very aggressively showed a specific kind of data. And this is something to be really careful with in both reading graphs on your own, as well as making them. Be very certain you aren't explicitly lying to people using your graphs. I've seen things where the x-axis is reversed to confuse people about the precession of time. Positive values are actually on the bottom instead of the top, so it looks like there's some kind of negative gain when it's actually a positive gain. Just really weird stuff. Yeah, it's Trigon. Tigran is correct. The matplot ibline command is for the Jupyter notebooks. It is not for any sort of independent IDE, which is interactive development environment. Yes. So maybe I don't want a line graph. Maybe I want a bar, because I think bar maybe will let me see the differences in between the months a little bit better. So it seems like 2 and 4 are a little bit lower. It makes sense. Some months have 31 days, other months have less than 31 days. It makes sense for February to have the least amount of births because it's the shortest month. So important things to keep in mind. There are external factors to the data that are not included in your data set that you must be careful of. Like February has 28 days most of the time. Cool. And so we're going to look at the days of the week. And so that doesn't look very good, does it? No, that's pretty bad. We don't even have the days of the week at the right, in the right order. So we need to do something about this. And we can actually specify a certain order in which they return the data to. This is very similar to what I did earlier with the columns. But here we'll use LOC. LOC stands for location. There is an equivalent command called ILOC, which stands for index location. For LOC, we can use the specific names of things. For ILOC, we like to use the index that they're located at. Or the number index, right? So for iloc, 0 would just be the first row, 1 would be the second row, etc. So here we specify the order that we would like the days in. Great. And then we use LOC to get those back in that order. And so now we can do some nice plots. And we see in both of the plots, births are actually significantly higher during the week. I think that this is probably because they try to schedule births when there's more staff at the hospital. I think, once again, I'm not a medical expert. I am not offering any medical advice here. But my conclusion would be that they probably want more staff in the situation of births. So they try to schedule more births for the weekdays. Great. And so we'll go down into our last little section. We've got like 3 more code blocks. We're almost done. I know this has been a long one, but I hope you guys have gotten a lot of really cool information out of this. I enjoyed it, and hopefully look up the school after. And I think we'll talk a little bit more about that after as well. So in this last little bit, we're going to be looking at the visualization for the smoking risk data that we did before. And so we already have our smoking risk data set above, right? And this is a really important reason why we save things to variable names, so we can use them later when we want to use them later. So we have our really long title, and we like to just split that in another line just for readability. As we can see, there are some pretty specific thresholds in which the graph jumps. So 0 to 1 is a big jump. I would say like, that's probably like 16 or more. And then greater than 22. And these are really big jumps in our threshold. And then it kind of plateaus off. So you kind of want to look at, oh, what actually happens here? And what am I actually looking at? Because it's kind of weird that we have this really big thresholds, right? And the data is not continuous. In an ideal world, you would see some kind of continuous relationship where the graph kind of just goes up, but not in these big steps. So we'll like to look at some of the data a little bit more. And so we want to say, the first thing we'd like to determine is we'd like to determine whether or not someone is high risk. And so we'll say that high risk is about 30% chance to be submitted to the NICU. So here is that 30% cutoff, but we use our simple Boolean statement to say greater or equal than to 0.3, which is our 30%. And we just get the first one, because that essentially gives us the value of how many cigarettes you need to smoke to be in the threshold. Because the amount of cigarettes smoked is our index. Great. And so we want to look at the data frame a little bit more in order to get a better idea. And I'm just going to run this so we can see the result. For the overall data. So now we're getting the percents, but we're also getting it split out a little bit more. And we're only looking at the individual groupings for SIGS-3. So instead of looking at 2 or more cigarettes smoked, I'm only looking at 2 cigarettes smoked in this line. And as we can see, we get some of these really big jumps because as we get further down into the data and the number of cigarettes smoked gets higher, the data becomes much more sparse. We have some smokers who at 60 cigarettes during the trimester, neither of those smokers had their children admitted to the NICU or themselves. And so, there are some situations where the sampling is just so low, right? There are not enough observations for you to observe the effect. And so it's important in these situations to sort of look at this and try to get an understanding of how this impacts your data and how this impacts the results that you're coming to. It could be something as asking for more data, trying to collect specific data based on that demographic in order to get a better viewpoint, or making sure that you proceed with caution in your analysis and understanding that that is just kind of a gray area and you won't really be able to determine exactly what's going on, but you should be able to get a really good gist. So the last 2 points I want to go through are after 10, the majority of smokers answer in multiples of 5. So this is a little bit of like a human psychology thing. It's the third trimester, that's a kind of a long time. Asking you how many cigarettes you smoked specifically during that period is kind of hard. So instead they'd be like, 20, I don't know, 15 maybe. Some people answer very specifically and other people do not, as well as the 99 category, which I assume is just 99 or more. Somebody goes in and goes, yeah, I smoke a lot of cigarettes. What box do I pick? And they go 99 and you go, great. And then you select the box. However, in the data, as we do move down, and this is really, really positively supported by this 99 category, it does seem like this is a very significant increase into the risk of having your child admitted to the NICU. And so I am no medical expert. But as common sense in our culture has told us, smoking is bad. Also, yes, cigarettes are sold in packs of 20. That does make sense a lot as well. So since we were doing the at least part, some of this data was hidden from us, which is why it was important to essentially come back at the end and check how these were actually stratified between the different groups. And with that, that essentially concludes the lecture part of the talk. I'd like to thank everybody very much for coming and for showing up. You guys had a lot of really great questions. I loved interacting with you guys throughout the lecture. It was a lot of fun. And I hope you guys found this really useful. I hope that you guys are interested in learning more with us and coming to hang out and learning some data science with us. We love meeting you guys. We love meeting the new students. And we hope that we get to meet you guys in a very short amount of time. You can check out the course offerings on our website, which there's a link to below. And you can also email us at admissions@nycdatascience.com in order to, get some more information about the program.
Yes. This was your first webinar, right?
Yes, this was my first webinar, and I'm trying to
But
scroll through some of these questions. I think
You went
there's.
really well. Is this similar to the format of the online courses?
I would say this is similar to the online residential. If you are a remote student in the residential program, you will have a live instructor talking to you through the lectures. If you take the IDL program, you watch pre-recorded lectures, but it's at a slower pace. And additionally, the instructors interact with you through office hours and through one-on-one meetings, more so in the IDL program. So that's the interactive distance learning, but the residential boot camp is much more like this, yes.
And one last thing is that our next cohorts are gonna be starting on September 27th, October 8th, and January 3rd, 2022. So feel free to check out our main website. And also, if you guys are interested in maybe starting a career in data science, we're gonna have an event next week, so next Wednesday. And if you really like the data visualization part, we're gonna have another event on October 6th, I believe. So I attached the links in the chat, but I'm gonna also send a follow-up email about it. Questions?
I believe at the moment there are physical, you can go into campus, yes.
Yes.
And the professor most of the time is on campus, yes.
Yes, and they're really nice. Like if you have questions, they're gonna explain everything. Yeah.
Mm-hmm. Yeah.
Other questions? Yes, Luke. Yes, October events are on Eventbrite, and if you would like, we have actually a webinar page on our main website. I'm gonna put the link below, so you guys can check our upcoming events and also past events. So maybe this one will be up tomorrow. You have to register for the upcoming events, but you can do it through the link I just sent in the chat. The deadline for January 3rd cohort is gonna be on, just seconds. It's gonna be, I think around December, yeah. But yeah, if you start earlier your application, you will gonna have access to our pre-work and you will have time to learn stuff. Yep. Other questions? If not, I'm gonna close it right now. Nice meeting you all. Have a good night. Bye.
See you, everybody. It was so wonderful lecturing for all of you.
Bye.
I hope to see you in class.